What's going on, guys? Christian here, and today we're going to be solving the palindrome number LeetCode problem. It's an easy one. So if you don't know what a palindrome is, essentially what it is the number or word that is the same forwards as it is backwards. So in this case, an example would be 121, top one. So 121 is the same forwards as it is backwards. Same thing for 1221. That's the same forwards as backwards. And in the case of negative numbers, those aren't going to be considered a palindrome because when you reverse them, as you can see here, it becomes, instead of negative 321, it becomes 321 negative, which isn't considered a palindrome. Here you can watch me live break down this problem. There's a couple of cases that I hadn't considered that I had to debug on my own, so you can watch me break those down and solve those live. Hope you enjoy the video. Let me know if you have any questions. Peace. The most obvious way to do this is to convert it to a string. I'll show you how to do that, and I'll show you how to do it without converting it because there's a follow-up. It's like a little bonus, I guess. It accepts both solutions though. So corner cases, or cases that we check for automatically that'll make it false, is if x is less than 0. That means it's negative. And as I showed you, that's already going to be false. So then we can convert this to a string, or it's pretty easy in Python. You just do that. And I usually like to keep track of the length. I'll just do it like that. Okay. And then we'll do it like this. We'll do a range instead of going through each letter, since we're going to be checking. What I want to do is like a two-pointer strategy. So look at the first index of the word, or of the string, and then the last index, and compare those two. If those two aren't equal at any point, then we'll return false. So it's really quick and easy to implement. So we'll do it like this. So then if x string of I doesn't equal to x string of x length minus 1, we subtract 1, obviously, because we're doing it based off of indices, and the last index of the array is the length, the number of elements in the array minus 1, and then we'll subtract that by I, so that as we're incrementing from the front, we're decrementing from the back, so we're comparing the right indices, and then we'll return false. If it makes it all the way through the list, or if it makes it all the way through the loop, then we'll return true, meaning that it is a palindrome. So we'll run it against the test code, or the test results. Oh, it's not S, my bad. Okay, that is true. And then we'll add the rest of the cases, make sure that's correct as well. Alright, looking good. Submit. Yeah, as you'll see, I already had a few submitted cases as well the last time I did this. Okay, so that worked. So that's the solution for converting it to a string. Now, the solution for keeping it as an integer, which is just a little bit different. It's similar to my last video that I did on, I think it was reversing a string. So we're going to do something similar to that when we're comparing it. So we're going to keep this first test case, because in any case when x is less than 0, it's going to be true. So let's see how we do this. We'll keep track of a reversed version of it. Yeah. So what we're going to be doing is, this is the algorithm we're going to use. We're going to be reverse equals to reversed times 10 plus x modulus 10. This is the formula I guess we're going to use. So here's an example of it. 1, 2, 3, 3, 2, 1. So I think we're going to be going from the last index to the first index. So from back to front. So we're going to grab this element first. So reverse is initialized to 0, right? So in this case, I'll keep track of reverse. Reverse equals 0, and then we'll keep track of x also. X equals 1, 2, 3, 3, 2, 1. Okay, so first we're looking at this first in x, right? So since reverse is 0, reverse times 10 is going to be 0 plus x modulus 10. So modulus 10, we're going to get that 1. So reverse is just 1. So then we're also going to have this. The double divide means it's like math.floor, so it converts it to an int. It rounds down automatically. Oh shoot, divide by 10. So then we'll divide this x by 10, take that off, take that off. I guess we can do this instead. Okay. So then we have this number that we're working with now. So then when we go through again and do this, we're looking at the last number. In this case we have 1, so reverse times 10, it's going to be 10, and then plus this 2, it's going to be 12. So then we keep doing this continuously, and we're going to get a reverse number. So we're essentially reversing the number, but we don't want to reverse the entire number, we just want to check for half of it. Want to make sure the first half of the string is the same as the second half of the string. So in this case we want to stop here, because if you remember, the original number was this. So we already checked for this half and we see that it's equal, so we don't want to keep reversing it. So we'll create a constraint that only goes through half the list. So we're going to create a loop now. So we'll do this. I'll go for, whoa, that was weird. I don't think we're going to do a for loop. I think we'll do a while loop. We'll do while x is greater than the reverse value. So as long as x is greater than the reverse, it'll keep going. So in the case that we find, like in the case that we were looking at, when 1, 2, 3 equals to 1, 2, 3, it'll break out of the loop because it's x is no longer greater than reverse. And we'll trace a couple examples to make sure that it all makes sense. So return if x equals to reverse, right? So if this is true, it'll return true. So I think there's theoretically that should work. I mean, obviously if it doesn't work, we'll trace. Okay, so we're getting all falses. So the first one should be true. Okay, so we'll trace this 1, 2, 1 example. Excuse me. Alright, so x equals to 1, 2, 1, and then reverse equals to 0. Okay, so we start, x is obviously greater than 0. We do this, we get 1 here, and then this is 12. And we go back, it's still greater, so we're going to continue iterating. So we get reverse is 10 plus 2, going to be 12. And this is not greater. Okay. So this is one of the cases we did not account for. So this is a pretty simple fix. We can put or down here, x equals to reverse divided by 10. So that'll cut off this last index here. Okay. Yeah, it'll cut off that last index there. So if that equals that, that should be true. So we'll run that again. Okay, so we're getting that true, but we're also getting a true for 10 for whatever reason. That's kind of strange. Hold on. I'm gonna pause for a second. Okay, so I took a second to decompose this question because I couldn't figure it out right away. So looking at x equals 10, when we reverse this, it's gonna have a floating 0 in front. So essentially it would be like 0, 1, 0. So in any case, a whole number will never start with 0. It shouldn't. So that's another case we can test for at the beginning. So if we do it like this, if x is less than 0, or x modulus 10 equals to 0, so that means that it checks for this. Because if that's the case, it shouldn't be a palindrome. Or the only case where it can be a palindrome should be or and. I think I'll put or for right now. Or x so if x equals 0, this should actually be true. I think actually no, it should be and this should be doesn't equal. Yeah, okay. So this checks to make sure that this first number isn't a 0. But if it is 0, yeah, if it is a 0, then it will return that this whole conditional is false. So it won't even return this false. It'll still go through here, do this checking, and it'll return this, which in this case it should be true if if it's just a 0, yeah, it should be true. Because single numbers can be palindromes as well. So we should run this. This should be good. Okay, and then we'll submit. Alright, cool. Alright, we got it. So that was an example of checking for an integer palindrome by converting it to a string and by leaving it as an integer. Let me know if you guys have any questions. That'll be it for now. See you on the next one.